This video is continuing talking about stoichiometry calculations. So in our last one, we looked at mole ratios. So now we're going to start putting it together. So I'm going to have a new equation that we're going to look at. Now this time they're going to start me out, instead of with moles, they're going to give me grams of one of the things, and it asks me to find grams of something else. So if I have 25.2 grams of this one, they want to know how much carbon it's going to take to react with that. So this would be like if you had a recipe and you were making cookies, and you knew how much sugar that you had, you would want to know how much margarine you would need to react with it. So I can't do anything, I can't go from one substance to another substance unless I have moles. So if I ever start out with grams of something, I'll call this grams of A, my first thing, I'm going to always have to get to moles. And I'm going to do that by using my molar mass. Then once I have moles of one thing, I can go to moles of another substance in my chemical reaction as long as I use a mole ratio, those coefficients. Then I could go to grams of that other substance and to go from moles to grams, I need to use my mole ratio, or my molar mass. Alright, so I'm going to first take my 25.2 grams of my B2O3, and I'm going to need to find my molar mass. So I'm going to take 2 B's and 3 O's and add up that mass. Okay, so I took 2 times 10.811, that was my boron. And I had oxygen, 3 times 15.9994. And I added those up to get 69.6202. So that's my molar mass. Now, since grams is on top, I'm going to need the grams on the bottom. So there's my conversion factor. Alright, so I did the first step. Now, since I have moles of this substance, I can find moles of carbon by doing a mole ratio. And since I have moles of the B2O3 on top, I'm going to put moles on the bottom. And according to my balanced equation, I have 2 because that's my coefficient. And I'm looking for carbon, so I have 7 moles of carbon. Okay, I've done step 2. Now I'm going to go to step 3, and this is carbon, so to go from moles to grams I'm going to need the molar mass, but I just have carbon, so I don't have to add a whole lot. I just know that in 1 mole of carbon, I look on the periodic table, and there's 12.011 grams. So I'm going to take 25.2 times 1 times 7 times 12.011. Then I'm going to be dividing by this number times this number. And a lot of times what I have students do is they multiply everything on the top and write it down. They multiply everything on the bottom and write it down, and then divide those two numbers. When I divide those, I got 15.2164 blah blah blah. Well, this is a very long number with many significant figures. This has many significant figures. These are counting numbers, so those are exact. So my beginning number had 3, so that means my ending number is going to have 3. So 15.2 grams of carbon. Alright, well, let's say we're going to use the same equation, but let's say that I'm still going to start with 25.2 grams of that term, but let's say they ask me to find carbon monoxide. Okay, so I still start with my same term, 25.2 grams of B2O3. Now they could have given me anything in the equation, but since I'm going to go grams to grams, I know it's going to take me those same 3 steps. So I still use my molar mass, and I had calculated that already. So my first step is the same. Okay, my second step is that mole ratio. This time I'm trying to find CO. So what I want is 6 of the CO. What I got is 2 of the B2O3. Alright, now I have moles of CO, and I need to find grams, so I'm going to need the molar mass. Okay, so I'm going to take those masses from the periodic table. I'm going to add those up. And I got 28.0104 grams per mole. So I have moles on the bottom, so 1 mole, and grams on the top, 28.0104 grams. So multiply everything on the top, and then we're going to divide by everything on the bottom. Alright, I got that. Once again, these have many digits. These are counting numbers or exact numbers. So I have 3. So I'm going to have 30.6 grams of CO. Alright, so that's a good example of a stoichiometry problem. If you had started with kilograms or something like that, you would first have to get it to grams. So you would have a conversion first to go to grams, but then you would still do your normal 3 steps.